This is a weekly summary of interesting news that is relevant for my lectures at the Eastern University of Applied Sciences. My name is Thomas Bocek, and today we will discuss 6 topics. The first topic is on Bitcoin and the Bitcoin price. It's the following article here. It's from Cointelegraph, and this reports that the Bitcoin dropped below 90,000 US dollar this week, reaching its lowest price in 7 months. And this represents a 28% decline from its all-time high over 126,000 in October. In this article, 2 investment executives believe the price may have hit bottom this week, but to be honest, you will always find 2 investment executives who believe it will either go up or it will go down. And the interesting aspect of this article is why it went down, and it's attributed to several factors. It's the large-scale liquidations in October and the uncertainty about the Federal Reserve interest rate decisions, outflows from exchange-traded fund and sales by major holders, and of course, geopolitical tensions. Bitcoin was the first major asset to decline before the broader market pullback, and the average Bitcoin ETF investor is now holding losses as the price fell below their entry point. And this shows Bitcoin isn't actually independent from traditional finance, despite being decentralized. When investors get nervous about the economy, AI valuations, or tariffs, they sell Bitcoin. And the decentralized network architecture doesn't isolate it from traditional markets or capital flows. And Bitcoin's price correlation with stock markets suggests the decentralized revolution oversimplifies reality. The network may be decentralized, but the capital flowing through it follows traditional patterns, and ETF outflows link it directly to institutional finance mechanisms. And as of today, the market already recovered a bit, so the Bitcoin is around 93,000, and I'm sure I will find 2 investment executives who say it will go down, and I will find 2 who says it will go up. For me, it's coin flip. It may go up, it may go down. I don't know. The next article is about TCP. It's a quite interesting article. It's the following article here. TCP is the backbone of internet communication, and it's the transport protocol that makes reliable internet communication possible. The underlying internet infrastructure is unreliable. Packets drop, get corrupted, duplicated, or arrive out of order. And TCP handles this, keeping the network infrastructure simple. TCP provides reliability through several mechanisms. Sequence numbers track which bytes each segment carries. Acknowledgement numbers indicate which bytes were received if packets arrive out of order or get lost. TCP detects gaps and requests retransmissions. Checksums verify data integrity. If bits get corrupted in transit, the checksum fails and the data is retransmitted. Flow control prevents overwhelming the receiver. The TCP header includes a window field that tells the sender how much buffer space the receiver has available. Congestion control prevents overwhelming the network itself. In 1986, the internet experienced a congestion collapse. It's also written here in this Wikipedia article. So the bandwidth dropped from tens of kilobytes per second down to 40 bits per second. And the problem was a feedback loop. When packets were lost due to congestion, systems retransmitted them immediately, and this added more traffic to an already congested network, causing even more packet loss, triggering more retransmissions, and the network essentially choked itself. And the TCP solution is congestion control algorithm that backs off when detecting packet loss. Instead of aggressively retransmitting, TCP reduces its sending rate, giving the network time to recover. And modern TCP implementations use algorithms that gradually probe for available bandwidth while backing off when congestion is detected. And me and my students, we are actively working on QATP and on QH. So QATP here, this is a UDP-based transport protocol that takes a simpler approach than existing protocols like QUIC, and the goal is to provide reliable transport with lower complexity. The next article is related to project management and Gen AI. It's the following here. Spec-driven development is gaining traction in AI-assisted programming. The approach generates product specification, implementation plans, and task lists before coding, basically a waterfall methodology for the LLM era. Tools like GitHub SpecKit or AWS Cairo and other products produce thousands of lines of markdown documentation to guide coding agents. And the author complains about the problems that mirror classic waterfall issues, context blindness. Agents miss existing functions that need updates, markdown madness. Developers spend most time reading verbose documentation, hunting for errors. Systematic bureaucracy, three-step design process creates repetitive specification with imaginary corner cases, false sense of security, and agents don't always follow the specs anyway. And the author argues this approach tries to solve the wrong problem, removing developers from software development. It requires both business analyst skills and developer skills to catch errors, so it doesn't actually remove developers. And this repeats the no-code tool mistake, promising no developer needed, but requiring developers to use them. And the proposed alternative is natural language development, iterative development with simple instructions instead of complex upfront specifications, break requirements into simple problems. The author built a 3D sculpting tool using short, vague instructions with Claude Code in 10 hours, no specifications. And when implementing simple ideas is cheap, small increments converge faster than big planning. And the important detail, software development is non-deterministic. Planning doesn't eliminate uncertainty. Agile methodologies solve this by trading predictability for adaptability. Coding agents should enhance this iterative approach and not resurrect waterfall documentation. The next article talks about heartbeats. It's the following here. This is a vital mechanism in distributed systems. Distributed systems, they need to know which nodes are alive, and heartbeat mechanisms solve this by having nodes send periodic signals. When heartbeats stop arriving, the system detects failure and takes actions like removing the node from a load balancer. The basic implementation has a sender transmitting heartbeat every n seconds with a timestamp and a sequence number, and the receiver tracks the last heartbeat time per node, and if time since last heartbeat exceeds a timeout threshold, the node is declared failed. Choosing a heartbeat interval involves trade-offs. Frequent heartbeats waste bandwidth. With 1000 nodes sending every 500 milliseconds, you get 2000 messages per second just for monitoring. Infrequent heartbeats delay detection, and the timeout must also account for network latency. And two communication models exist. Push model has nodes send heartbeats to monitor, for example, to Kubernetes or to Hadoop. And pull model has the monitor query the nodes used by load balancers and, for example, Prometheus. Many systems combine both for redundancy. And for large clusters, gossip protocols, distributed detection, each node exchanges heartbeat information with random peers, and this eliminates central bottlenecks, but means nodes may temporarily have different views on the cluster. The author also mentions network partitions that create split brain problems where isolated groups both think the other failed, and also discusses possible solutions. It's a very interesting article, a deep dive into heartbeats, something that sounds simple, but in practice difficult to make it work right and efficient. The next article describes here the move from AWS to Hetzner, and they could cut the cost by 90%. They were paying over $3,000 per month for Atlas on AWS, and $1,000 of those just went into the database instance itself, and $1,000 for the internet data transfer. And the high transfer cost came from their multi-cloud architecture designed to avoid single points of failure during outages like the recent AWS incident. And Hetzner offered a dedicated server with 8 cores, 256 gigabytes of RAM, 4 NVMe's SSDs with RAID 5 for $160 per month, and compare this with the Atlas M4 with 8 vCPUs, 16 gigabytes of RAM, and 380 gigabytes of SSD. The specs are way better and the cost is much lower. Hetzner also charges no data transfer fees between application server and database. And the migration involved taking a Mongo dump of 500 gigabytes of data, restoring to the new server, and syncing changes during the migration window. They run Proxmox on the host machine with MongoDB in Docker on a Ubuntu VM. Traffic routing uses traffic as reverse proxy and for SSL termination. And the VM sits on a private subnet with NAT, network address translation, and port forwarding handled by the host. Self-hosting means taking more responsibility. They use Ansible for server provisioning, MongoDB with cron for daily backups to Hetzner storage boxes, OpenObserve for monitoring and log aggregation, UFW for firewall, and WireGuard for VPN connections. Atlas monitoring was useful, but wouldn't let them kill connections via the admin command when they hit a connection limit due to application bugs. And with their own server, they can now manage connections directly through the MongoDB shell. And performance improved because of the better specs, allow index to be held mostly in memory, and the team acknowledges that do-it-yourself approach works for them as a small team with limited servers, but may not scale for everyone. And they also mentioned that when they grow, they might see value in managed solutions again. The last article for today, it's the following here, with actors that we already discussed in a previous in the news video. So I mentioned this Cambodian pig butchering scheme that were caught, and now China accuses US of orchestrating a 13 billion Bitcoin hack involving this Cambodian scanning group. China's cybersecurity agency accused the US government of orchestrating a 13 billion Bitcoin theft from the Luabin mining pool in December 2020, and China claimed this was a state-level hacker operation rather than a typical criminal behavior. The Chinese government has recently become more vocal about accusing the US of hacking campaigns, though their allegations tend to lack forensic details compared to other accusations from other countries. In August 2025, China's Cybersecurity Association accused the US of exploiting vulnerabilities in Microsoft Exchange servers to steal military data and launch cyber attacks on Chinese defense companies. And the US Department of Justice charged the founder and chairman of Prince Holding Group for operating a forced labor scam compound in Cambodia, which I reported on, that ran cryptocurrency investment fraud schemes. And the Prince Group operated at least 10 compounds in Cambodia since 2015, trafficking hundreds of workers and forcing them to execute scams under threat of violence. And it remains unclear how the Bitcoin came to be in US custody or whether a theft actually occurred. So the article and the details, they're just not in those articles, and I couldn't figure out what actually happened. Everybody is accusing everybody, and I'm curious about what's actually going on. Nevertheless, stay safe. This is a kind reminder that there is no free money, and if somebody says so, he probably wants to scam you. See you next week, and next week for sure we talk about the Cloudflare incident.